Question number 11. In hydrogen spectrum, the shortest wavelength in Balmer series is lambda. The shortest wavelength in the bracket series will be, now dear student, in Balmer series 1 by lambda, in Balmer series this should be equal to jumping to the second energy level from the infinity level. So this is equal to R by 4. Whereas the bracket for the shortest wavelength, the jumping from n infinity to n is equal to the 4 is equal to R 1 upon 4 square minus 1 upon infinity square, that becomes R by 16. Now if you compare this one, so 1 by lambda prime is equal to R by 4 into 1 by 4, but R by 4 is 1 by lambda. So therefore lambda prime is equal to how much? 4 of lambda. And your answer 2 is 4 lambda. So answer to this question is second option. The question number 12 says, as the quantum number increases, the difference of the energy between the consecutive energy levels decreases, increases, remains same, first decreases, then increases. Now dear student, you know that the energy level, as you move from first level to second level and then to third level, this difference decreases because the energy has the formula of minus 13.6 divided by n square, and this level gradually decreases with the increase of the quantum number. So answer to this question is the first option, decreases. Question number 13 is, the ionization potential of hydrogen atom is 13.6 volt. An electron in the ground state of hydrogen atom absorbs a photon of energy 12.75 electron volt. How many different spectral lines can be expected in the emission spectrum? Ionization potential means the energy required to take it from n is equal to 1 to infinity, and in the ground state it is absorbing, here the energy is minus 13.6 electron volt, and it absorbs the energy from outside 12.75 electron volt. So it will go to the next higher levels, and therefore the new energy will be equal to minus 13.6 electron volt plus 12.75 electron volt, and that becomes equal to minus 0.85 electron volt. How many different spectral lines can be expected in the emission spectrum? Now to find the number of spectral lines, we will find to which level it will jump. So if E is equal to this one, then 0.85 is equal to minus 13.6 divided by n square, and you solve this, n comes to be the 4. So electron jump from n is equal to 1 to n is equal to 4. Now how many number of lines are possible? And that you can go directly by the formula n into n minus 1 divided by 2. N was equal to 4, so it is equal to 4 multiplied by 4 minus 1 divided by 2. So the 6 emission lines are possible. So answer is the fourth option. The question number 14 is, the Lyman series transition involve the largest changes of energy, smallest change of energy, largest change of the potential energy, both 1 and 3. Now dear student, Lyman is just at the bottom, n is equal to 1, and when electron comes from infinity to this one, you know this there has the maximum energy change. In hydrogen spectrum, this value is minus 13.6. And what were the potential energy? The potential energy on this value is minus 2 into 13.6, which is double of this one electron volt. So maximum change occurs when it jumps from here to here, then in other series like Balmer or the bracket series. So largest change in energy is there, and the largest changes of potential energy occurs there. Therefore the correct answer is option number 4. Question number 15, for an electron in the second orbit of the Bohr hydrogen atom, moment of the linear momentum is given by. Now dear student, according to Bohr model of hydrogen atom, the moment of momentum, also called angular momentum, which was MBR, and that is equal to n into h upon 2 pi, right, where n is 1, 2, 3, the principal shells. In the second orbit, the linear momentum will be, this will be equal to n is equal to 2 h12 pi. So that become equal to h1 pi. So option should be h1 pi, which is option number 4. So the answer is the fourth choice.